Our project is the integration of open source controls and sensors in a low-cost desktop CNC mill. The goals for our project were to come up with customizable open source software and firmware, functionality verification. We were also tasked with implementing robust safety systems, an automatic tool changer, fourth axis, a Raspberry Pi computer to control those add-ons, as well as mechanical bed leveling. After the background research phase was completed, the next step was to implement the designs using software such as SOLIDWORKS, KiCad for electrical design, and MATLAB. Any mistakes that were made would be done during this phase, and they could be worked out in the software prior to actually using materials. This allowed us to save resources and stay within budget. The software we chose to control the system was Universal G-Code Sender with the Gerbil-HAL firmware. This software is open source and customizable, allowing for full flexibility over the software controlling our system. Some of the safety features we implemented can be seen here. We added a safety switch to the door so that if it's open, the machine will stop, as well as the emergency stop button and a status indicator light. The verification phase of our design involved the collection of and analyzing data using software such as Excel and tools such as accelerometers, temperature sensors, a tachometer, and a dial indicator. This clip shows the electromagnetic interference that we discovered in our system along the way. The solution to this problem we're recommending to next year's team is a shielded cable for the variable frequency drive controlling the spindle. Here we have the testing of the laser tool probe that we developed and integrated into our tool changing magazine. When the beam is broken, the Z position will be recorded. And here we have the successful test of a 3D printed tool being unloaded from the spindle using the tool changing magazine and software that we developed. And finally, we have the testing of the entire system, the software controlling it, the electrical, the motors, the calibration, etc., all coming together, resulting in a completely open source CNC mill that is affordable and can produce quality parts out of materials such as woods, plastics, and even metals like aluminum and brass.